You have probably seen the video. Maybe it showed up in your recommendations 2 days ago. A dramatic thumbnail, an urgent title. Voyager 1 turned around and made a discovery we can't explain. Millions of people have watched versions of that story. Voyager's sensors reorienting toward the solar system. A mysterious signal. Something out there answering back. And here is the problem. Almost none of it happened. Voyager 1 did not turn around. It physically cannot turn around. Its antenna is locked onto Earth and has to stay locked onto Earth, because the moment it looks away, we lose it forever. But before you close this video, stay with me. Because buried underneath all of that fabricated drama, there is a true story, a 48-year-old spacecraft that nearly died 15 billion miles from home. A team of engineers who performed the equivalent of brain surgery through a 45-hour time delay. And 3 discoveries in interstellar space that are genuinely, honestly unexplained. Not clickbait unexplained. Peer-reviewed, published in Nature Astronomy. This is the real story of what Voyager 1 found out there. And it is better than anything the clickbait channels could invent. Subscribe if you genuinely enjoy the video. First, let's kill the myth properly. Voyager 1 launched on September 5th, 1977. And it exists because of a piece of luck so absurd it sounds made up. In 1965, a graduate student at NASA's Jet Propulsion Laboratory named Gary Flandreau noticed that Jupiter, Saturn, Uranus, and Neptune were drifting into an alignment that would let a single spacecraft slingshot past all of them, stealing speed from each planet's gravity as it went. That alignment happens roughly once every 176 years. Miss the window, and you wait until the middle of the next century. NASA did not miss it, and that is why, today, a machine built before personal computers existed is the most distant human-made object in history, roughly 165 astronomical units from the Sun. That is about 24.5 billion kilometers. A radio signal moving at the speed of light takes more than 22 hours to reach it, and that spacecraft is aimed permanently at one thing: us. Its high-gain antenna points at Earth, held steady by small thrusters, because its transmitter puts out just 23 watts of power. Less than the bulb in your refrigerator. By the time that signal crosses 24 billion kilometers, it arrives at Earth almost unimaginably faint, and it takes 70-meter dishes, antennas the size of football fields, just to hear it. Turn the spacecraft around to point its instruments backward, and that whisper vanishes into the noise forever. So no, Voyager 1 did not turn around 2 days ago, or 2 years ago, or ever. But something did happen. And it is the event that every one of those clickbait videos is unknowingly built on top of. In late 2023, Voyager 1 started speaking gibberish. The signal was still there. The spacecraft was still alive, still transmitting, still holding its lock on Earth. But the data coming down was corrupted, scrambled, unreadable. For a team at JPL that had been decoding this spacecraft's voice since 1977, it was like a family member suddenly speaking in a language no one had ever heard, and they had to diagnose the problem with one hand tied behind their backs, because every command they sent took 22.5 hours to arrive. Every response took another 22.5 hours to come home. Ask a question on Monday, get your answer on Wednesday. Now imagine debugging a computer that way. You form a theory, you write a command, you send it, you wait almost 2 days. The answer isn't quite what you expected. New theory, new command. Another 2 days. And hovering over every single decision is the knowledge that one wrong instruction, sent once, could kill the mission permanently. There is no reset button. There is no repair crew. There is no second Voyager 1. It took months, and when the engineers finally isolated the cause, it turned out to be almost heartbreakingly small. A single memory chip inside the flight data system had failed. One piece of 1970s hardware, after 46 years of continuous operation in the harshest radiation environment any human machine has ever endured, had quietly given out. About 3% of the system's memory gone, and the code stored there could not be repaired. So the team did something remarkable. They relocated it, they carved the affected software into pieces, tucked those pieces into spare corners of the spacecraft's remaining memory, rewrote them to work from their new locations, and stitched the whole thing back together. Remotely, across 15 billion miles, on a computer with less memory than a car key fob. And in 2024, Voyager 1 came back. Clean data, full science operations. The spacecraft that was supposed to die in 1981 had survived again. That is the real event behind the mystery signal videos. Not aliens, a chip, and a group of human beings who refused to let go. Now here is the twist, because if you came for a discovery we can't explain, you're still getting one. You're getting 3. When Voyager 1 crossed the heliopause in August 2012, the boundary where the sun's solar wind finally gives way to interstellar space, it became the first object in human history to sample the space between stars from the inside. And almost immediately, the data started disagreeing with the models. Discovery 1. The magnetic field. For decades, the prediction was clean. Inside the heliopause, the sun's magnetic field. Outside, the galaxy's magnetic field, pointing in a noticeably different direction. Cross the boundary, watch the compass swing. Voyager crossed the boundary. The compass barely moved. The field direction on the outside looked strangely similar to the field on the inside, so similar that scientists spent years arguing about whether Voyager had actually crossed at all. It had, which means the boundary between our solar system and the galaxy is not a clean wall. It is something more tangled, more porous, more connected than anyone predicted. Discovery 2, the density. Interstellar space was supposed to be a quiet, thin, roughly uniform medium. Instead, as Voyager 1 pushed deeper, its instruments measured plasma density climbing. Not fluctuating, climbing steadily, year after year, to dozens of times what it measured just after crossing. Nobody expected a gradient like that, and nobody fully agrees on what causes it. Is it material piling up against the outside of our sun's protective bubble, like snow against a plow? Is the local interstellar medium layered in ways our models never captured? Those are open questions in active research right now in 2026. And Discovery 3, the strangest of all. The hum. Starting around 2017, Voyager 1's plasma wave instrument began picking up a faint, persistent, narrow-band emission near 3 kilohertz. Not a burst, not a one-time event. A continuous tone in the plasma of interstellar space detected across hundreds of millions of miles of Voyager's path, published in 2021 in the journal Nature Astronomy by a team led by Stella Koch-Ocker. This is not an alien signal, and no serious scientist thinks it is. It is the interstellar medium itself vibrating. But here is why it matters. That hum is the first continuous, real-time reading of the plasma between the stars that humanity has ever obtained. And what it reveals is that interstellar space is not the silent, empty void of the textbooks. It has texture, it has structure, it has, in a very real sense, weather. Every model we built from inside the solar system, looking out through telescopes, missed that. It took putting an instrument physically inside interstellar space to hear it, and we only have one instrument out there. Which brings us to the part of this story that is genuinely a countdown. Voyager 1 is powered by 3 radioisotope thermoelectric generators, blocks of plutonium-238, whose decay heat gets converted into electricity. At launch, they produced around 470 watts. Today, the output has fallen to roughly half of that, and it drops by about 4 more watts every single year. There is no recharging it. There is no fixing it. It is radioactive decay, and physics does not negotiate. So the team at JPL has been making brutal choices. Of the 10 instrument packages Voyager 1 carried at launch, most have already been switched off, one by one, in a carefully planned triage. Each shutdown is permanent. Each one closes a set of questions forever. Only a handful of instruments remain, and sometime in the early 2030s, the power will fall below the minimum needed to run any of them. The last signal will leave the spacecraft, travel for nearly a full day, arrive at Earth, be recorded, and then there will be nothing after it. And here is a date worth knowing. Later this year, in November of 2026, Voyager 1 will reach a distance of 1 full light day from Earth. So far away that light itself, the fastest thing in the universe, needs 24 hours to make the trip. No human-made object has ever been that far from home, and Voyager will cross that line while it is still alive, still transmitting, still doing science. And when the silence does come, the story still doesn't end, because bolted to Voyager's frame is the golden record. Greetings in 55 languages. The sound of rain, of ocean waves, of human laughter. 90 minutes of music, and a map of pulsars showing exactly where in the galaxy we live. Long after the transmitters go cold, that record rides on at roughly 38,000 miles per hour through darkness with nothing to stop it. It will still be traveling when the sun swells into a red giant. It is quite possibly the most permanent object our civilization has ever made, and it is attached to a machine that runs on less power than a light bulb. So no, Voyager 1 did not turn around. It never looked back, not once in 48 years. It has spent every moment of its existence doing the opposite, facing forward into a region of the universe no instrument has ever touched, whispering home what it finds. And what it has found, a boundary that behaves like no model predicted, a medium growing denser when it should be fading. A faint hum in the space between stars is real, unexplained, and running out of time to be studied. When Voyager goes quiet, no replacement is funded, no replacement is built, and the next spacecraft to reach interstellar space would take decades to get there. The window is closing. The least we can do is pay attention while it's open. If you found this interesting, hitting the like button genuinely helps YouTube show it to more people who would appreciate it. And subscribe if you want to be here for the next one, because we are going to talk about the spacecraft that flew into the atmosphere of the sun and what it found inside a star.